Hi friends, welcome back to my YouTube channel. So today we are going to discuss wireless LAN IEEE 802.11. So this is a topic from Computer Communication EC 407 Module 2 from Electronics and Communication Engineering BTECH syllabus. So it is from KTU syllabus and also this is from Module 2. So let's go to the video. So previously we have discussed about Mac IEEE 801, a wired LAN IEEE 802.3. So now we are going to discuss about IEEE 802.11. So this is a wireless LAN. So wireless communication is one of the fastest growing technologies. The demand for connecting devices without the use of cable is increasing everywhere. Wireless LAN can be found on college campus, in office buildings, and in many public areas. So we concentrate promising wireless technologies for LANs. IEEE 802.11 wireless LAN. Sometimes it is called as wireless Ethernet. So although the protocol need several layers to operate, we concentrate mostly on the physical layer and the data link layer of IEEE 802.11. So basically in this topic, we are mostly concentrating the physical layer and data link layers of IEEE 802.11. IEEE has defined the specifications for a wireless LAN called IEEE 802.11, which covers the physical and data link layer. So, architecture of the wireless LAN of IEEE 802.11. The standard define two kinds of services: the basic service set BSS and the extended service set ESS. So basic service set means IEEE 802.11 defined the basic service set BSS as the building block of wireless LAN. So it is a building block of wireless LAN BSS, and a basic service set is made of stationary or mobile wireless station and an optimal central base station known as the access point. So there might be a stationary base station and a mobile or wireless station and a one central base station known as access point. So figure shows two sets of in this standard. So the figure we can see there are so much stations are there. So ad hoc network a BSS, the basic service set without an access point, and there is another one infrastructure that is BSS with an AP. So there are several station and one access point. So the BSS without an AP access point is a standalone network and cannot send data to other BSS. It is called ad hoc architecture. In this architecture, stations can form a network without the need of an AP. They can locate one another and agree to be a part of a BSS. A BSS with a AP is sometimes referred to as infrastructure network. And next we are going to discuss about extended service set. So extended service set ESS is made up of two or more BSS with access point. In this case, the BSS are connected through a distribution system, which is usually a wired LAN. So the distribution system connect the APs in the BSS. So the distribution system basically connect the APs access points in the BCs. So IEEE 802.11 does not restrict the distribution system. It can be any IEEE LAN such as Ethernet. Note that the extended service set uses two types of station, mobile and stationary. The mobile stations are normal station inside a BSS, and the stationary stations are access point stations that are part of a wired LAN. So figure shows that the ESS system. So there is a distribution system, and distribution system is connected to the access point, and each BSS has this access point, and one of the BSS, one of the station is connected to other BSS also. So this is the figure for extended service set, and we have already covered the BSS also. This is the important the architecture part of the wireless LAN. So when BSS are connected, the stations within reach of the one another can communicate without the use of an AP. However, communication between two stations in two different BSS are usually via two access points. The idea is similar to the communication in a cellular network. If we consider each BSS to be a cell and each AP to be a base station, note that the mobile station can belong to more than one BSS at the same time. So we have the different station types. So IEEE 802.11 define three types of stations based on their mobility in a wireless LAN. No transition, BSS transition, and ESS transition mobility. So a station with no transition mobility is either stationary, not moving, or moving only inside a BSS. So that is no transition mobility. A station with BSS transition mobility can move from one BSS to another, but the movement is confined inside one ESS. That is all about BSS transition mobility. And third one, a station with ESS transition mobility can move from one ESS to another. However, IEEE 802.11 does not guarantee that communication is continuous during these moves. So these are the three types of station types. Now transition, BSS transition and ESS transition mobility. So next we are going to discuss about the MAC sublayer of IEEE 802.11. So basically it defines two MAC sublayer, the distributed coordination function DCF and point coordination function PCF. So figure shows the relationship between the two MAC sublayer and the LLC sublayer and the physical layer. So the first rectangle is called LLC sublayer IEEE 802.1, and the second and third one is PCF and DCF, and the last one is physical layer. So data link layer is the first three layers are including the first three layers, it is data link layer, and the last one is physical layer. So first we are going to discuss about the DCF. So you can use this figure in the answer sheet also for the MAC sublayer of 802.11. The distributed coordination function DCF is one of the two protocols defined by IEEE at the MAC sublayer is called distributed coordination function DCF. So DCF uses CSMA bar CA as the access method. So CSMA bar CA we have already discussed previous lesson. So carrier sense multiple access collision avoidance is the access method. And wireless LAN cannot implement CSMA CD for the three reasons. For a collision detection, a station must be able to send data and receive collision signals at the same time. This can mean costly stations and increased bandwidth requirement. Second point is collision may not be detected because of the hidden station problem. So the hidden station problem we will discuss later. And the third one is the distance between stations can be great and signal fading could prevent a station at on end from hearing a collision at other end. So these are the reasons why we cannot implement CSMA CD in wireless LAN. And now we are going to discuss about the flowchart of CSMA CA in wireless LAN. So this is the figure. So there is a start when we start to send the data, set back off to 0, and there is a persistence strategy. Wait DIFS. So we'll discuss DIFS, what is DIFS and what is RTS. So wait DIF, send RTS, set a timer, CTS, received before timeout. If it is yes, then wait for SIFS and send the frame and set a timer. Acknowledgement received before timeout. If yes, then it is success. If no, it will go increment back off. And CTS received before timeout. If no, then again it will increment the back off. And back off limit, yes, then it will abort. If it is not, wait back off time. Then it will start from the beginning. So now we can discuss about start. I just want to give you an overview. Then now we can start. So the process of flowchart. First one is before sending a frame, the source station senses the medium by checking the energy level at the carrier frequency. The channel uses a percent strategy with the back off until the channel is ideal. After the station is found ideal, the station wait for a period of time called the distribution interframe space. So DIFS means distributed interframe space. Then the station sends a control frame called the request to send RTS. Second step is After receiving the RTS request to send and waiting period of time called the shorter interframe space SIFS. The destination station send a control frame called clear to send CTS to the source station, and the control frame indicate that the destination station is ready to receive the data. The source station sends the data after waiting an amount of time equal to SIFS. And the fourth one is the destination station after waiting for an amount of time equal to SIFS sends an acknowledgement to show that the frame has been received. And acknowledgement is needed in this protocol because the station does not have many means to check for the successful arrival of its data at the destination. On the other hand, the lack of collision in CSMA CD is a kind of indication to the source that data has arrived. The figure shows a process of flowchart for CSMA used in wireless LAN and the collision during handshaking. So, what happens if there is a collision during the time when RTS or the handshaking period? Two or more stations may try to send request to send frames at the same time. These control frames may collide. However, there is a mechanism. There is no mechanism for collision detection. The sender assumes that there has been a collision if it is not received a CTS frame from the receiver. So the backup strategy is employed and the sender tries again. So this is happening in the collision detection. So frame exchange timeline. So figure shows the exchange of data and control frames in time. So there is a source and destination and all other stations. No carrier sensing is means nav. And network allocation vector. So what is network allocation vector? How do other station differ sending their data in one location, one station acquire access? So how do other station differ sending their data in one station acquire access? In other words, how is the collision avoidance aspect of this protocol accomplished? The key feature is called nav. So, network allocation vector. So, when a station sends and request to send frame, it includes the duration of time that it needs to occupy the channel. So, the stations that are affected by the transmission create a timer called network allocation vector. So, it is a timer and it is giving the transmission create a timer called network allocation vector that shows how much time must pass before the station are allowed to check the channel for idleness. Each time a station accesses the system and sends the RTS frame, the other station starts their nav, that network allocation vector. In other words, each station before sensing the physical medium to see if it is ideal, check first check its nav to see it is has expired or not. So figure shows the idea of nav. So there are DAFS and request to send, it goes to destination, and there is a SIFS, and then it will say to the source that clear to send, and there is a SIFS and it will send the data, and from the destination it will acknowledge it and acknowledgement is sent to the source. So this is happening. So at that time all other station is in nav. So that means it will be a timer that is created for the all other station and that will be ideal. So this is all about network allocation vector. So that is all about today's section. So we will discuss this in the next section. We will continue this section in the next lesson. So if you like this video, please subscribe my channel, like, share and comment. Thank you for watching my video. See you in the next class.